Okay, let's take a look. Okay, so a few things that is again, when you do QA, you want to look for specific tests that is very common. Example, this is found in your QA list. Sodium hydroxide in your QA list. This is in your QA list. This is in your QA list. Aqueous ammonia, everything is in your QA list. So this one is directly memorized of what you have in your list. So once you pop sound, you know that this thing here is hydrogen. And because it forms hydrogen with the acid, that means this gray residue here should be a metal. Because only metal, when it react with hydrochloric acid, you get hydrogen gas. And then this part here should be the salt. So what does the salt contain? Silver nitrate white PBT. This is the test for chloride. And confirm as a chloride, you react with hydrochloric acid, you definitely will get a chloride. So the white PBT for chloride test, this is your standard silver chloride, which is basically the test for chloride ions. If it's chloride present, you get white PBT silver chloride. So this is our first unknown. And from here, it tells you that this salt here is a chloride salt. First test, anyone, any question? Okay, if no questions for this, let's look at the aqueous ammonia test since it's on the right side. White PBT soluble in excess aqueous ammonia. There's only one of them. There's only one, which is zinc. So this white PBT here is zinc hydroxide. How do I know? It's all from the QA list. So zinc is the one that is soluble in excess aqueous ammonia. So this tells us that zinc 2+ is present. So that means this colorless solution is zinc chloride. So if you backtrack some more, that means this metal F here should be zinc, because zinc react with hydrochloric acid, give you zinc chloride and hydrogen gas. Okay, so this is basically to test for positive ion, and this positive ion is tested to be zinc. So our F here is zinc metal. Okay, any questions on the right branch? Okay, if nothing else, sodium hydroxide test. Let's take a look at the brown PBT, insoluble in excess. Brown PBT, there's only one only. Iron 3 hydroxide. And this, again, sodium hydroxide is also a test for positive ion, which means that the E here, this thing here has iron 3+, because you test it with this, and it gives you the result that iron 3 is present. Okay, and the last test here, we have barium nitrate test. This is, again, test for sulfate. And if you get a white PBT, that means in this case, your white PBT here is barium sulfate, which tells you that this substance here has a sulfate, because you test the E here for sulfate and you test for the positive ion. So the P, we would have barium sulfate, which means that substance E has both sulfate ion and iron 3 ion. This is iron 3 sulfate. Okay, simple. Any questions, anyone? to precipitate. Ionic equation for the precipitate, again, our hack. We say that for precipitate, always write down the precipitate first. And then ask yourself, what are the ions that make up all this precipitate? So it must have come from a barium ion and a sulfate ion. And then both of them must be AQ because PPT formation is two solutions mixed together, give you the precipitate. It's always like this. Just like T, for example. Oh, sorry, T is silver chloride. Oh, I did the wrong one. So let's say if it's T, the PPT is silver chloride. Same thing, the solid, where does it come from? It comes from silver and it comes from chloride. And the two of them will be AQ, AQ. Same thing. What about zinc hydroxide PPT? Same story. The PPT is zinc hydroxide, solid. Where does it come from? Zinc ion and hydroxide ion. But because of the two below, I need to have two hydroxide ion with one zinc, aqueous, aqueous, solid. PPT ionic equation is just like that. All right, questions, anyone? If not, I move on to 6B. Or rather, question 6. Okay, let's go on to question 6. Okay, so they are all from the same period. So they are in the same horizontal row. So when you see this strong basic oxide, there's only one, which is all the way to the left-hand side, group 1. This thing actually describes group number 1, because group 1, when they form strong basic oxide, they dissolve into water, they form alkaline. So on right or the left, we have W in your group 1. X, it says, is covalent. Covalent, that means it's on the right-hand side because the non-metals are on the right-hand side. Z says produce an ion, negative ion. So this is also left-hand side. So I know that X and Z, they should be non-metals. And then Y is an ionic compound, so Y is a metal. So if you look at the compound, Y2O3, oxygen is 2 minus. So what must be the charge on Y in order to get this? So if you look at the charge and the formula is 2 and 3, this guy has to be 3 plus. So that when you cross the formula, Y is 3, O is 2, the charge, you crossed it, you get Y2O3. In order to get this combination, Y has to be a positive 3. So if it's a positive 3, that means it loses 3 electrons to be stable. And therefore, Y should be in group number 3. Okay, for W and Y, any question? That's how we look at this. Especially for Y. Okay, digest this 10 seconds, I move on to the other two. Okay, let's look at the non-metals. It says it's Z minus. Z minus, that means it gains 1 electron. Gains 1 electron, that means it should be in group 7, right? 7 valence electron, then gain 1. So from then, Z, you should get something from group 7. Because it gains 1 electron, it should be from group 7. And the last one, XCl3. And because it's covalent, that means most likely it combines with chlorine like this. So let's say chlorine is circled. In order for the formula to be like this, it should be something like this for our X. And then on top, there should be two more that's unbonded. So the atom of X, it should be something from group 5. So that each of these will combine with a chlorine, combine with a chlorine, and combine with a chlorine to get your XCl3. So it has 5 valence electrons. So this guy here is in group 5, which is just okay, any questions for the grouping for WXYZ? So one of the things for group 1, we say that their melting boiling point normally is very, very low. So expected to be low melting boiling point. Copper expected to be high melting boiling point. How do I know? Because metals are considered in the middle of the periodic table. Transition metals. Transition metals have properties that is very typical of what you understand, what you will perceive the metal to be. What do I mean by that? That means if you take the piece of metal to hit your head, you feel that it's painful because it is hard. Whereas for group 1 metal, it is soft. How soft is it? It can be cut by knife. Okay, so this is the two main comparison between the differences between the group 1 and the non-transition and the transition metals. If you really want to also compare specifically to copper, this is only for copper. Copper is reddish brown in color in terms of the metal, and then for most metals is gray. So if you really want to insert that, also can. Now this is differences in the physical properties. Now what about similarities? Okay, what's the same between both of them? Number 1, both they are good electrical conductors. In either solid state or liquid state. They are both malleable and ductile. Okay, all these are the similarities in physical properties. Of course, no need to write. The question only asks us for differences. Okay, any questions for me? If no question, let's look at number 7. Those who haven't cleared this yet, give you a minute to go through question 7 and also help me jot this down. So the increase in temperature will tell you that this thing here is an exothermic reaction. An observation will be temperature rise. So conclude about the reaction here. This is an exothermic reaction, and mainly because the temperature increases. I think that's all. So 3 different metals here. They have varying maximum temperature reach. Okay, so student concluded the order to be something like this: most reactive, okay, let's move on to this. So do you agree with this? So what happens to this reaction is each metal is added to the magnesium chloride. So we are actually looking out for displacement. We are looking out for displacement reaction. So if you look at temperature difference, there's zero temperature difference. In this case, the temperature rise is plus 5 degrees Celsius. This is plus 4 degrees Celsius. So if this was all added into magnesium chloride, so I would expect to see, based on this concept, that when the reaction occurs, there is a temperature increase. So, and that if displacement is indeed exothermic reaction, then the larger the exothermic reaction, then the metal should be more reactive. So if you look at this case, the increase in temperature when M is added to magnesium chloride versus N added to magnesium chloride, both are expected to have a reaction because of this. So the increase in temperature for M is plus 5 degrees C, for N is plus 4 degrees C. So based on these two, right, I would say that M is actually more reactive than N because of the higher temperature. And since both of them can displace magnesium, then the order must be from the topmost reactive. As you move down, N is less reactive because of the lesser temperature gain. And then L, nothing happens. That means L cannot displace magnesium. So L is all the way at the bottom. Okay, so this part here is actually displacement reaction. So the order should be, most reactive should be M and magnesium followed by L. So this is not correct. Okay, before I write down in text, anyone has any questions regards to the arrangement first? The larger the temperature difference, the more reactive the metal compared to magnesium. Question, anyone? If not 10 seconds, I move on to the writing. My stand will be, in this case, the student result does not agree with the conclusion. Okay, let's write this. So do the
magnesium is not the most reactive one.
Because these two guys can displace him, because when the displacement occurs, temperature went up, right? So that means,
okay.
yeah. So let's prove that both M and N is more reactive than Mg. Yeah. So for this case, does the student agree? No. Answer is no. So first off, I'll state that in this case, the displacement of magnesium from magnesium chloride, because the reaction is you throwing the metals to displace the magnesium. I'll say that the reaction here is exothermic. So based on this, right? Okay, metal L does not experience an increase in temperature. So therefore, it shows that L cannot displace magnesium. So therefore, L is the least reactive, because it cannot displace magnesium. The other two metals, they can. Then I'll talk about both M and N. Able to displace magnesium, and hence the temperature actually increases due to the displacement. So okay, then I'll say that N is actually more reactive than M. Okay, N is more reactive because the displacement actually produces more heat for metal N. So therefore so I'll say in this case, the order shown by the conclusion is not correct. Okay, understand the concept. The temperature that spikes higher, more reactive. Carbon monoxide production, there's only one. You have to say incomplete combustion. There's no other way. So at Orchard Road, we are talking about cars and everything. So the proper phrasing will be incomplete combustion of fossil fuel in the combustion engine of cars. Do not say burning of fuel. Burning of fuel may not produce carbon monoxide. It has to be incomplete combustion. Okay, parts B. So the concentration is a bit different. So the timing. Notice from 8 to 10, the timing has the highest concentration. So from 8 to 10, what's actually happening? So most likely 8 to 10 is due to the peak hours where the vehicles are used when people use the vehicles, especially using cars for their mode of transportation. Okay, so in this case, I'll mention that the concentration of the CO is highest from 8 a.m. to 10 a.m., possibly due to the peak usage of vehicles during the busy period. Okay, a reason for the concentration of carbon monoxide to be higher over the 2 years. So no matter what, you will notice that from all timings, 2002 always higher than 2001. So if you have more produced, most likely it is due to there are more cars on the road. So there are more cars on the road from 2002, then you will produce more gas, more carbon monoxide during the interval. So the only logical reason for this is probably this due to a higher there's a higher ownership of a higher ownership of vehicles in 2002. Okay, compared to 2001. So this will lead to more carbon monoxide forming for the same period of time or same period of the day. Okay, generally just due to more cars. They belong to the same group. Okay, so you notice that all of them, the formula here is C3H6, C4H8, C5H10. So you can say that all of them have the same general formula of CnH2n. Something like that. Oh, 1 mark only. So that's all we need. Okay, put a tick to show the statements, blah, blah, blah. Okay, for those of you who have not done this question yet, 1 minute, go and tick. We talk about same percentage by mass. Is confirmed same percentage by mass because for the first one is, you see the ratio is 3, 6, 4, 8, 5, 10. So the ratio for all of them, right, is 1 carbon to 2 hydrogen. So no matter how many you have, it's also always 1 to 2. That's why the ratio is always the same. They have the same empirical formula. Empirical formula is the lowest form. So from all of them, right, C3, 3, 6, 4, 8, 10, 5, 10, they can all be reduced to CH2, which is the simplest formula. The simplest formula is also known as the empirical formula. So both of these are correct. Unsaturated means that they have CC double bond. Is wrong, they don't have it. That's why this is a false statement. Now, this is the sneaky thing. Normally, decolorized bromine is CC double bond, but the question here says it's sunlight. Okay, so let's do a comparison here. If you have CC double bond, okay, it will just decolorize the bromine in all situations. Okay, this is under addition of bromine. Okay, they will put in and then you test for CC double bond present or not. But what if you don't have CC double bond? Okay, you don't have CC double bond, it will still be able to decolorize bromine, but only in the presence of sunlight. This is not addition, this is the substitution. Substitution reaction. So let's go through this a bit. So for example, if I have the, let's say ethyl. So this guy has a double bond. So you plus bromine. Then the CC double bond is broken. You get the 2 bromine attached to it. This is under addition of bromine. So you get decolorized. With bromine decolorized. Now, what about ethane? No double bond, and then you have the bromine again. Now, if you have sunlight, then you undergo substitution, the 1-for-1 exchange thing. And you get bromine here and HBr. See, this is slightly different. This thing here, the bromine will also decolorize because there is sunlight. Under normal circumstances, only those with CC double bond will decolorize. But if they give you sunlight, then substitution can occur. Okay, this reaction here is not called addition. This is called substitution. Okay, so this is the difference between these two. Okay, if you have forgotten, please help me jot this down. So with this, we have the formula is C6H12. We also follow the same format. They move in a loop. They don't have CC double bond. All looks like this. Okay, that's all for part C. Yeah, help me jot this down. Then we go to 11. Owen, we discuss later if you got a break in between. Either I'm okay with it. Okay, so why the time stays after 6 minutes? So over here, why the gas no longer produce? Daryl, if you look at question 11, the reason why the reaction stopped is because one of the substance used up. Look at the question, which substance is used up? Any idea there? If Daryl can hear me. Reaction comes to a stop for 6 minutes. The question here says magnesium, excess hydrochloric acid. So because of the excess hydrochloric acid, we should think that the magnesium is the one that is used up. Got it there? Because acid excess, so must be magnesium used up. Got it? So we'll say over here, reaction comes to a stop. It's actually happening in the reaction. We have magnesium plus hydrochloric acid. We get MgCl2 plus H2. So this thing here is an aqueous solution. So what are the ions present? We have magnesium ion from here, from the magnesium salt. Then you have the chloride ions. Now the last ion is the one that a lot of people couldn't get it. It's actually H plus ions. Why is that H plus ions? Okay, this thing here gives us Mg2 plus and Cl minus. Don't forget HCl. This guy is in excess. Because it's in excess, there's also H plus and Cl minus from here. So the ions, number 1, number 2, number 3. This is due to the excess HCl that is present. Hence, you got the H plus. Okay, if no question, let's go to point D. So one change that could increase the rate of reaction. So the easy way is to, let's talk about temperature, all right? Because particle size, I think the last question, the last paper we had it. So let's go for temperature increase. So you need to say temperature increase, Ke rise, the particles move faster. And as a result of the particles moving faster, the frequency of the collision increase. And then we talk about frequency of effective collision increase, and then the rate of reaction will increase. Okay, that's for our D.
Do you have to say what the reactant particles are?
You can say you can, but not important.
So in this case, what do I say? Magnesium and hydrogen and chloride molecules.
You can, but you see, because when you write that, right, you are saying that the HCl is a molecule, but technically when it becomes acid, it's no longer molecules already. So to take away all this technical stuff, you just need to mention that the frequency of collision, you can just say between particles increase.
Okay.
Don't have to name the particles. Yeah. All right, so let's look at this. So this is the experiment is repeated using 0.3 grams of magnesium. The question asks us for the volume of gas. So if we already got the equation here. So moles of magnesium, we can find it by using 0.03 over the usual MR of this is 24. So you get the moles, and then the moles of hydrogen will be the same. And finally, the volume of hydrogen will be the moles multiplied by 24 dm cubed. And then we'll get our answer for this. So numerically, I have 0.72 moles of magnesium. Ratio is 1:1. So this is also 0.72. Then we multiply by 24 dm cubed. Wait, I think I got something wrong. Okay, my moles are all wrong. I press multiply. So this should be 0.00125, 0.00125. So it's 0.3 dm cubed, but the question wants to be in cm cubed. So I multiply by 1000. I get 30 cm cubed. This is for part 1. Okay, the mole party, 0.03 grams of magnesium. How will graph B look like? Now, this is our original graph. This original graph is 0.06. So now my graph B is 0.03, everything remaining the same. So I will expect the volume of gas produced will be half of it, because remember, magnesium here is the limiting reagent. So the amount of gas you get should be half, but rate of reaction should be the same because nothing has changed. So from here, same gradient. This is our graph B. This is original. Okay, that's all. Okay, if no question, then let's move on to 13. Sorry, 12. Let's look at which of the reactions can actually increase the rate of reaction. So for step one, we have stirring. This one will increase rate of reaction. Step 2, crush, increase rate of reaction. Using of yeast, this is a catalyst. It will increase rate of reaction. Warm place, increase rate of reaction. So the step that doesn't have anything to do with increasing rate of reaction is number 5. Okay, next. Yeast is your bread-breaking nonsense, right? All these they contain bacteria. So bacteria cannot stand high temperature. So you need to cool it down before the yeast is added. So the reason here will be that the yeast, we use the term, okay, the proper term is denatured, but we cannot remember, just use cube is fine. Okay, that's all. Let's go to triple I. The name of the process of this wine making, this process here, as we seen in making of fermentation of sugar. So the process here is for fermentation. If the structural formula of the main compound form in this structure. So fermentation actually produces ethanol. So the question asks you to draw ethanol. So ethanol, there's 2 carbon, and then there is the OH. Alcohols contain OH, and the rest of the bonds, they will all be hydrogen. Equation, is it important? I don't feel it's that important because not that important. But let's put it here. Sugar is C6H12O6. Ethanol, based on the formula here, I have C2H5OH. And byproduct of fermentation is carbon dioxide gas. Okay, and for balancing, we always try to remember it's a 2-2 behind. Okay, the functions of yeast. The purpose here is that okay, we say that it acts as a catalyst. Right, to increase the rate of reaction. Okay, next are the name and chemical formula of the compound that causes the sour taste. So it will oxidize to ethanoic acid, right? So that's the name we have here. The name is ethanoic acid because of its oxidized. After a long storage, you get oxidized by oxygen in the air. Okay, and then to decide the formula, we always draw the acid structure first. Remember, this is the acid structure. And ethanoic acid has 2 carbon. So we do another extension out, put another carbon. So there's 1 carbon here, 2 carbon here. And then the rest is all hydrogen. CH3COOH. So for part 2, how is it formed? As we mentioned, this is very likely to cause by the oxidation of ethanol by oxygen in the air. Okay, for oxidation, the way to do it is always get the alcohol plus O2 to give you the acid plus water. This is the easiest way to remember. So we have the ethanol formula is C2H5OH from here. Oxygen. The acid is here. CH3COOH plus H2O water. Sure balance. Okay, this is the way we do it. Greasing. So greasing will be oil. Oil will be forming a barrier, creates a barrier. So for part 1, okay, we'll say produce provide. The barrier between the metal and the oxygen water. Prevent rusting. Okay, number 2, why it can be placed in aluminum containers? Because aluminum, we say that has a layer of aluminum oxide. So we say this coating actually prevents the food from coming, you can say coming into contact. Okay, so coming into contact with the metal directly. So with this barrier, the food don't interact with the reactive metal. Okay, part 1, part 2, any questions? If not, I'll move on in 10 seconds. Okay, next triple I. This one is good to remember. Ammonium nitrate and water, these two combination is endothermic. Okay, so generally we say that ammonium salts. Okay, dissolves in water in what we call it's an exothermic reaction, so the temperature will decrease and then it can act as a cold pack. This one. Okay, let's go to filament IV. So the purpose of this is a noble gas. So we will say that argon actually provides what we call an inert environment. So this is basically meaning unreactive environment. So if the filament what happens if it's placed in air? Okay, so because in a light bulb, the filament will become hot. Okay, so when we say that when the filament becomes hot, it will react with the oxygen in the air. Okay, and then when the filament, after reacting with the air, okay, it will form the oxide of the filament. And when it turns into an oxide, it cannot conduct electricity. Okay, any questions? So as a metal oxide concept, the concept is that the metal oxide is actually ionic. So ionic in a solid state. Cannot conduct electricity. So your light bulb will fail. So inside the light bulb, we should fill it up with something that's not reactive like argon, and then do not fill it up with air. Okay, let's look at oxidation state. Elements is 0. Sodium in a compound is +1, group 1. This one is +1. Oxygen is -2. Hydrogen is +1. Same thing, -2, +1. Now, this one is special. If you put hydrogen as +1, right, then +1, +1, the whole thing cannot equate to 0. So for this case, I have no choice. The hydrogen has to be -1. Only in this case. So why is this redox? So two things. I can say water is reduced because it loses oxygen gas to form H2. Okay, H2O becomes H2, lose oxygen gas. And then I can say for NaH, oh, this one it says in terms of redox or oxidation state. So I cannot use the oxygen. But anyway, I do the NaH first. NaH has been in this case oxidized. Because oxidation state, you notice in our hydrogen, it increases from -1 in NaH to +1 in sodium hydroxide. Okay, so this is the hydrogen comparison. Then if you want to talk about the reduce, so now I cannot use the oxygen. So I'll use same thing is also between water and hydrogen. So in this case, I'll say that H2O is reduced because the oxidation state of the hydrogen element it decreases from, in sodium hydroxide, the H is +1. So it's +1 in, the H2O is +1, the hydrogen in H2O, to 0 in hydrogen. So there's a reduction here. Okay, and then we end up with, since there is both, okay, so we'll mention that since there's both oxidation and reduction, the reaction here is considered to be redox. That's for part 1. Okay, next, reducing agent. Reducing agent is the one that is oxidized. So you can see that the one that's oxidized here is NaH. NaH has been oxidized. So the reducing agent is NaH, and the one that's oxidizing agent. The question didn't ask for oxidizing agent, but we'll just do as practice. So the one that's oxidized, the oxidizing agent will be the one that's reduced. So it's actually H2O. Okay, H2O, this one, okay, this is because it oxidizes. This one is because it is reduced. Okay, any questions for B part 2? Right, last question. Identify reducing agents. So I will use oxidizing agent to identify reducing agent. The easiest oxidizing agent you can use acidified KONO4. So when it's placed in a reducing agent, These colors, the solution here will change from purple to colorless. So that will be the proof for the presence of the reducing agent.